Okay, so 6-3 is all about logarithms, which is a relationship between the exponents. So basically back in the Renaissance, because there was no cell phone or TV, they were like, okay, well, we know 2 squared equals 4, and we know 2 to the third power equals 8, but what if there was a number in between? What if it was like 2 to the x power equals 6? What would x be? And so this one guy was like, I think I can figure this out with a relationship. And the relationship that he created is logarithms. So really the only thing that we're doing is we're rewriting exponential to the relationship of the logarithms. And the easiest way to think about it is that the base of your exponent becomes the base of your logarithm. And you can see it's in the base because it's like almost like it's in the basement. It's smaller, it's lower, that stuff. And so we would say, if we were to say this out loud, it would be the log base 2, that represents what's in the basement, of 8 equals 3. So that's how we would say it. So the first half of the homework is really just like rewriting it. It's not even any math. You don't have to think about it. You just have to rewrite it according to that rule. So we have example 1.1a on the left-hand side. It says 5 squared equals 25. So I'm going to take my base of the exponent, which is 5, and I'm going to say, all right, this is log base 5. And then the other two numbers, they switch places. And you are also going to include the equal sign. So log base 5 of 25, because it switched places with the 2, equals 2. And that's your answer. That's it. You just have to rewrite it. So the one beneath it is just like it. Log base 10. And even though we have complicated numbers, it doesn't matter. We're just going to write it as is. So it'd be log base 10 of 0.1 is equal to negative 1. Now, there were a lot of questions about, like, should I add my parentheses? And, like, technically you do not have to. But some people, like, they just prefer to do it, and that's fine. You definitely need a parenthesis if it was like x plus 25 or x minus 0.1 or something like that. So if you had multiple things in the log, then yeah, you would definitely need parentheses. But you can actually get away without doing it if it's just a single digit, if you will. All right. So again, even if you have a fraction, it doesn't matter. This is going to be log base 8. And then the 4 and the 2/3 switch places. And that's the answer. So then that's forward. So if we want to go backwards, it's the same idea. My base of the log is 2. So I'm going to write that as the base of my exponent equals. And then the 16 and the 4 change places. You just have to make sure when you do this that the 4 goes to the exponent of the base, because otherwise it wouldn't be a base. It would just be a number. So it'd be 2 to the 4th power equals 16. And then you can actually plug this into your calculator and make sure it works. So 2 times 2 times 2 times 2 does in fact equal 16. So then the next one, again, 4 is our base this time. So it'd be 4 to the 0 power equals 1, which again makes sense because anything to the 0 power equals 1. And then the last one is super easy. My base is 12, and then the 1 and the 12 switch places. And so, yeah. So I think there's like 8 questions in total on the homework that are related to these two examples. So it's very, very simple. You're just rewriting it. All right, so then what if they did not tell you what it equaled? And that's what example 3 is all about. Let's say that they didn't give it to us. Well, anytime you don't know what it equals, you can say it equals a variable or equals x, because x is supposed to represent what we don't know. So I can now change this into exponential form. 4 to the x power equals 64. Now, you could use your calculator and just plug into the calculator 4 to the 1st power, 4 to the 2nd power, 4 to the 3rd power, and figure out what would that be, what would x have to be in order to get 64. However, on the quiz, you will not have the graphing calculator. You will have a 4-function calculator from Mrs. Marshall. So we are actually supposed to try to rewrite 64 in terms of 4, and this is how you do it. We're going to do upside down division, where we take what we're trying to change and divide it by the base, because we want to write it in terms of 4. So 64 divided by 4 is going to give me 16. Divide that by 4, and we get 4 again. So I can actually rewrite this as 4 to the x power is equal to 4, and I had it 1, 2, 3 to the third power. And now it's really easy to see that the x and the 3 are the same number. So x equals 3. Okay? Same idea with the one on the right-hand side, that log base 3 of 81. Again, we don't know what it equals, so we say equals x. Rewrite it as exponential format. 3 to the x power equals 81. We need to rewrite 81 in terms of 3. So I'm going to have 81 divided by 3. That's going to give me 27, which gives me 9, and that gives me 3. So now I can rewrite this as 3 to the x power is equal to 3 to the fourth power, because I had it 1, 2, 3, 4 times. And I can see that x is going to be equal to 4. So a lot of times you're going to have to do the work for it, but every once in a while you'll have a really easy one, like log base 3 of 3. We set it equal to x, and it becomes 3 to the x power equals 3. And if you don't see an exponent, it's always an understood 1, which means that now I can clearly see that x is going to equal 1, and this is our answer. So sometimes it's super easy, which is great, and every once in a while it's not. So what if we had a situation like the other b on the left-hand side? It says log base of 1/5 of 125 equals x. Well, I'm going to start off the same. It's going to be 1/5 to the x power is equal 125. So when you have a problem like this, notice that our base right here is 5, and I need to actually get this larger number in terms of 5 as well. So I'm going to go ahead and I'm going to do that. It's going to be 125 divided by 5. 125 divided by 5 is 25. Divide that by 5, and we get 5. Okay, so I can rewrite this to say 5 to the third power. But I can't say that the answer is x equals 3, because if I do that, it's going to give me, if I plug it into the calculator, like parenthesis 1 divided by 5, parenthesis raised to the third power, it's going to give me a really small decimal. So I actually have to make it negative. And so that's like a note that you should probably write off on the side. If a fraction is equivalent to a whole number, or even vice versa, whole number, all right, so even if a whole number was equal to a fraction, then your x is going to be equal to a negative number. Your x is going to be equal to a negative number. And it makes sense because back in chapter 5, I think it was, we did sort of talk about this, and we did a couple examples. We had we had 2 to the negative second power, and we said the exponent was unhappy with where it was at, and so you had to change floors to make it happy, and then you were able to solve. All right, so the same idea applies over here. We have a fraction, it becomes a whole number, and so because of that, we have a negative answer, a negative exponent. All right, let's do an easy one. C at the bottom is the same idea. Just wanted to point out really quickly, there are certain decimals I expect all of my Algebra 2 students to know. That is including 1/2 is the same thing as 0.5. I feel like I should not have to do this, but yet here we are. 1 divided by 3 is the same thing as 0.3 repeating. 2 divided by 3 is going to be 0.6 repeating. 1 over 4 is equal to 0.25. 3 over 4 is equal to 0.75. And then you have your 5s. 1 divided by 5 is 0.2. 2 divided by 5 is equal to 0.4. 3 divided by 5 is equal to 0.6. And 4 divided by 5 is equal to 0.8. So these are common decimals and fractions that we should all have memorized. It's very, very common in algebra, so, and SAT and ACT, so it's just good to know. You can data dump it when you graduate high school. How about that? And if you're not going to college. But if you're going to college, you should probably keep it for that as well, at least until you get all your math credits. Either way, we have log base 5 of 0.2. I can look up at the notes that I just wrote about decimals, and I can see that 0.2 is 1/5. So I'm going to rewrite this. All right, it says equals x. It's going to be log base 5 of 1 divided by 5 equals x. So then I do my exponential function. 5 to the x power equals 1 over 5. All right, again, we have that same situation as before. A fraction turns into a whole number. All right, thankfully, my bases and my denominators are already the exact same thing, so I know that I'm not really changing the exponent. It's going to be 1, but because it flips, it's going to be a -1. And the same thing happens with the other letter C. All right, so the last scenario that you have to worry about in this particular section is letter D at the bottom. So it says log base 36 of 6 is equal to x. So we can change that into exponential form. 36x is equal to 6. Now, at the beginning, we had a smaller number, 4, raised to the power of x equaled a larger number. So it wasn't a big deal. We could plug it into our calculator. 4 to the first power. That doesn't equal 64. Keep going higher. 4 to the second power also does not equal 64. Got to go higher. But this time, my x is associated with the larger number. So I actually have to figure out a way to make my larger number smaller and not through division, which would have been really nice, but that's not the position we're in. So instead of going higher or up from 1, we're actually going to go down into some fractions. So the easiest way that I like to explain this is that we could easily change the 6 to 36 by squaring it, all right? But obviously 2 is bigger than 1. It makes my number bigger. So instead of having 2, I'm going to make it the reciprocal, which is 1/2. And now it's smaller than 1. It goes smaller. So I'm going to say, all right, well, this is going to be x equals 1/2. And if you want to double check it, you can. 36 to the 1/2 power. This is going back to chapter 5 again, and also the radical section that I taught in quarter 1. I can change this. Remember, your denominator becomes the index of a radical, and so it's going to be the square root of 36, which everybody should know is equal to 6. So I was successful in making my large number smaller. So the other note you should probably write is that if you have a smaller number, smaller number going to a larger, other way around. If you have a larger number going to a smaller number, then x is going to be a fraction. X is going to be a fraction. Okay? And just for the record, don't think it's going to be like anything complicated. It's not going to be like 11 divided by 6. That's not a thing. It'll be something easy like 1/2, 1/3, and really just those two. It'll just be one of those two. So, you're welcome. So every once in a while they do like to do a negative fraction, like it's the same idea, but you would just have your fraction and it would also be negative, but that's usually going to be saved for like honors, to be honest. Anyway, so we can move on to the next little bit, which is our common logarithms. This is definitely on your quiz, 100%. You will literally have a question that says, what is the understood base of log? And the answer is right here. Basically, people commonly work with base 10 because, well, the entire world works with base 10 unless you're doing computer work. In that case, it's base 2 because it's binary numbers. So people got really lazy about putting log base 10, and so they just started putting log, and now it's an understood log base 10. So one of the questions on the quiz is, what is the understood base of log? And the answer is 10. Same thing happens with the natural log, because remember, 6-1 was all about money, and if we did 6-2, then we would have also discussed the natural number and how it relates to money, but we're not doing that. So really, all I need you to know is that if you see ln, this is not I, this is not I-N, this is ln. That stands for the natural log because e is the natural number. So if the question said, what is the understood base of the natural log, or ln, the answer would be e, the natural number. All right? And yes, the L and the N are like switched from the natural log. I understand it. I understand most people are like, shouldn't it be NL? No. Technically it's Latin, and they like rearrange things in Latin apparently. So it's going to be the natural log is ln. Thankfully, your calculator actually has all of this for you, so we can go to that really fast and we can just type it in. Okay, so here is the calculator that you guys should have. If you look next to 7, you can see the word log, and the one underneath it is ln. It's a lowercase l, it is not in. Please do not write in, that it's just wrong. Don't do that. But the question is, what is the what is the log of 8? Now, because this calculator, which can program the base, but we're not going to do that. We're going to use the buttons that are provided here. This log does not have any base information, so we know this is already in the correct base. We're just going to click it. It's very, very simple. So it's going to say log 8, and we're going to press enter, and we get the answer 0.903. So I'm going to go back over here, and I'm going to say that this is going to equal 0.903. And then I'm going to go back to my calculator. They want me to find the natural log of 0.75. So I'm going to go back. Natural log is beneath log. It's right here. I highlighted it in red accidentally, but I did it. ln 0.75 is equal to negative 0.288. The instructions on my notes say round to 3 decimal places. Make sure you double check your homework. It might ask you to round to 2 decimal places or 4 decimal places. But knowing me, I probably changed the decimal places because I wanted to be extra. Anyway, so we are going to go back, and I'm going to write that answer. It's going to be negative 0.288. And that's it. So far, we haven't really done anything difficult, but I will say it's definitely new. It's very different than most things that we have done before. The next couple of problems on your homework are going to be what I like to call concept checks. It's not really anything that you have to like calculate or do anything like that, but you are going to have to just double check that you understand the concept. And the concept is, if your base of the logarithm is equivalent or the same number as the base of your exponent, you are allowed to cross them out. And it doesn't matter the order. You can have the log first or your exponent first. It doesn't matter. So in the one beneath it, the base of my exponent and the base of my log are the same, so we are able to cross them out. And our answer is just whatever we did not cross out. That's it. So in the first one, top left-hand corner, it says 8 to the power of log base 8 of x. So I see that my bases are the same, so I'm going to cross it out. What I did not cross out was the x, and so that is our answer. Just a concept check. That's it. All right? The one beneath it, same exact idea. Log base 7 and the base of the exponent 7, cross out. What I did not cross out was negative 3x, and that's our answer. I will say, though, every once in a while they do like to hide the information. So if you look on the top right-hand corner, it says e, which is that natural number, raised to the power of ln. Wait, hold on. We definitely talked about ln. If you look at the top of the page, it says ln is the abbreviation of the natural log base e. So you know what? Let's just rewrite this. Make sure we can see everything. ln is going to be rewritten as log base e of 20, and now I can clearly see, even though they were hiding it at first, I can clearly see that my base of the exponent and the base of the log are the same. So my answer is 20. Sometimes they even hide it further. I have the final problem here, log base 2 of 64, raised to the power of x. 64 can actually be written as a form of 2. So I'm going to do what I did earlier. I have 64. I'm going to divide it by my base, which is 2. That gives me 32. Divide by 2 again to get 16. Divide by 2 to get 8. Divide by 2 to get 4. Divide by 2 to get 2. Okay, so I'm just going to rewrite log base 2. I have 64 next, so I'm going to replace it in terms of 2, which is 2 to the 6th power. And then just make sure you carry whatever was in the exponent with it as well. So it's now reading as log base 2 of 2 raised to the 6x power. All right, now it's clear to see my bases are the same, cross them out, and the only thing I didn't cross out was 6x. And so that is our final answer. It is a concept check. But most of them are really, really easy and really quick, so you don't have to worry about it too much. Okay, last problem is example 5. And I made sure to have one problem for each one of your homework problems, if that makes sense. So when you go to the homework, if you are stuck, you should look at these examples because we're going to do all 6. There should be one in all of these examples that matches with what you do in the homework. Might be out of order, but anyway. So this one is asking for the inverses. And if you forgot how to do inverses is when we, first of all, we switch x and y. All right. So anytime you have f of x, it's the same thing as having y equals. So I'm just going to rewrite that. So step 1, switch the variables. All right. So x equals, instead of y equals, 6 to the y power. All right. Step 2 is we have to solve, or actually let me say isolate y. That's our goal. And I'm just going to give you a quick little hint. If you start in exponential form, that means you should end in a logarithmic form. And if you start in a logarithmic form, you should definitely end in exponential. All right? So currently in this problem, I am in exponential form. I need to be in the logarithmic format and watch what happens when I do that. All right, so I'm going to change this. It's going to be log base 6, and then the x and the y switch places. So it's going to be y over here and x over there. And now, is y isolated? Yes, it is. And so this is our answer. I was able to isolate it immediately, which is great. Every once in a while, there'll be an extra step. It's not a huge deal. So let's go down to letter B underneath. I need to, first of all, switch my x and y. All right. I am in exponential form, so I need to change it to logarithmic. So it's going to say log base e. And now my 3x and my, oh, sorry, not my 3x, my 3y. Let me fix that. 3y is going to switch with my x. So my x goes over here. My 3y goes over there. Is y alone, though? Well, no, we have that 3 with it. So I need to divide by 3 so that I can get y alone. So my answer is going to be y equals log base e of x over 3. And since it's log base e, remember I can use the abbreviation ln, the natural log, of x over 3. And this is our answer. You could be, a little bit extra if you wanted to and make it 1/3 natural log of x. It doesn't really matter. It all means the same thing. But this is your final answer either way. All right, letter C, same idea. We have that one step that we have to deal with before we do, all of our fun stuff. So step 1, switch your variables. Okay. And I have never changed my logarithm to exponential or vice versa when I had a plus or a minus. It hasn't really come up yet. So when this happens, just make sure that your exponent and the base are isolated. So currently I have the 5 to the y power, which is what I want, but I have that minus 9. So I'm going to add the 9 to the other side. And now the exponent is by itself, and I can do that log switcheroo. So it's going to be log base 5, and the y is going to switch with everything on the other side. So the whole thing, x plus 9. So now this is when parentheses are important, because if you just put x, some people might interpret that as, oh, it's just x, a part of the relationship of log, but it's not. It's x plus 9. It's a unit. Shocking how that keeps popping up. So on the left-hand side, I have y. On the right-hand side, it's going to say parenthesis x plus 9. And this is our final answer. All right, so that has been all exponential going to logarithmic. So let's do the opposite of that, logarithmic to exponential. First things first, change your variables. Log base 2 of y. And again, we started with log. We need to transfer it to exponential. So the base of my log becomes the base of my exponent, and x and y switch places. So it's going to say y equals 2 to the x power. And that's your answer. All right, what if you had some extra numbers like this? And I'm actually going to write this as no, I'm not. I'm going to write it as log base e, since we have the natural log right there of 10x, of 10y, my bad. All right, I'm going to change it into exponential. So it's going to say e as my base, and the 10y and the x switch places. So the x comes here, 10y. Y is definitely not alone. I got to divide by that 10 on both sides, and I get y equals e to the x power over 10, or if I want to be fancy, 1/10 times e to the x power. Final one, we have x equals log, I'm going to go ahead and just change ln to log base e, parenthesis y plus 3. All right, I have a log format. I need to change it to exponential. So e becomes my base. X is going to switch with the unit of y plus 3. So it's going to be y plus 3. And then I can see I still do not have y by itself, so I need to subtract on both sides. E to the x and negative 3 are not like terms. Please do not try to add them. That is weird and incorrect. So your answer should be y equals e to the x minus 3. They're not like terms, so you just sit them next to each other and call it a day. And that is how you find the inverses of logarithms. So you do have 24 problems on the homework, but again, a lot of it is just rewriting or simplifying, so it's not super difficult. Only the last 5 have these types of problems. If you have any questions, let me know.